Okay, so we've got this massive number here, 7 to the power of 7 to the power of 37. Now, I wouldn't even try and calculate this. This is going to be so many digits, we probably wouldn't fit it on this board or this board either. So, and then dividing that by 19, it's just going to take you all day. So we're going to have to use some number theory kind of information to try and solve what happens when we divide this by 19. What we're looking for is the remainder. So ideally what we're looking for is 7 to the power of 7 to the power of 37 is congruent with some possible number, which we'll call m, modulo 19. So that's basically what we're looking for. So where do we start with this? Well, a good place to start is to try and get rid of the top tower, 7 to the power of 37. So let's have a look at that. So 7 to the 37. Now we see that 37 plus 1 is 38. Let's just write this down over here. 37 plus 1 equals 38. And then half that, we get 19, which is prime. So what we can do is here, we can have a look at this, modulo 19. And what we say is this is modulo 19. Okay. So with that, what we can say is that we have phi of 19. So that's the Eulers Totient function. Phi of 19. Well, as 19 is prime, it's got 18 co-prime divisors. So therefore that equals 18. And our next goal is to find phi of 18. So now what we do is we look for phi of 18. Now we can list all the numbers 1 to 18 and work them out, or we can do another formula for finding Eulers Totient function. So for 18, we know that 18 has its prime factors of 2 times 3 times 3. So from that, we can take its unique prime factors are 2 and 3. So unique prime factors are 2 and 3. So to find phi of 18, that equals 18 times 1 minus 1 over first prime number, that's 2. And we multiply that 1 by 1 minus 1 over 3. So just simplifying this up, we get 18 times 1 minus a half is a half. 1 minus a third is 2/3. So then that will be 36. This out, we've got 18 times 1 times 2, which is 36. Divide that by 2 times 3, which is 6. So it equals 6. So therefore we say phi of 18 equals 6. Okay, so now that's going to be really helpful now when finding 7 to the 37. So the last number we looked for was 18. So now what we say is 7 to the 37 mod 18 is 37 reduced by multiples of 6. So now that this will lead us to 7 to the 37 minus 6 times some integer k is congruent with 7 to the power of something with this property. So if we let k equals 6, 37 minus 36 gives us 1. So then that is congruent with 7 to the power of 1, which is just 7. Okay, right, that's really helpful. We've now reduced this 7 to the power of 37. So because we've gone through this Eulers Totient function, this is valid now, just to substitute 7 to the 37 just for the number 7. So now what we can say is 7 to the power of 7 is congruent with a number m modulo 19. Okay, right, 7 to the power of 7 modulo 19. Now we're in good position now because 19, 7 and 7, these are all prime, co-prime with each other. So let's break down this 7 to the power of 7. So 7 to the power of 7, we can say that that is 7 squared times 7 squared times 7 squared times 7. Now, we can find out what 7 squared is modulo 19. That's going to be really helpful. So let's just write on here 7 squared modulo 19. So mod 19, that equals some number r. That's our remainder. So that should be a 19. Let's just write that in there better. Modulo 19. Well, we know that 7 squared is 49. So 49 will give us minus 8. So then that will give us 7 squared is congruent with minus 8 mod 19. So as we're in modulus 19, we can substitute minus 8 for all of these numbers. So now we get minus 8 minus 8 minus 8 times 7. Okay, need to try and simplify this up a little bit more. This is still a little bit too big to handle modulus 19. Well, we know that 7 eighths are 56. So minus 56 modulus 19 is just going to be positive 1. So let's just write that on here. Minus 56 is congruent with 1 modulo 19. If we add 57 onto minus 56, we get positive 1. So now we can cancel these out, and these can just become 1. So now we have minus 8 times, so minus 8 times minus 8, that will then give us 64, and then modulo 19, that is congruent with 7 modulo 19. So therefore our remainder of this is going to be 7. So what we can say is 7 to the power of 737 is congruent with 7 modulo 19, and that is our answer.